Dr. Camille Alleyne. She is a real NASA engineer, and I think she will talk about working at NASA more, maybe.
A licensed private pilot, and she was a finalist in the 2004 astronaut selection program. So, without further ado, I'll turn it over to Dr. Alleyne, and please join me in welcoming her.
Saw you is from Baikonur, right in your backyard, so I knew kind of where it was, but I've never been here, so it's really cool to be here. I was in Uzbekistan last week, and I just got here yesterday. I'm only going to stay here a day. Then I go to Kyrgyzstan, and then head back home to Houston, Texas, where I live. So, a lot of traveling, right? But I really came to like share my story, and hopefully you guys could be, and girls could be inspired by my journey, what I've done. Just a little bit about myself, and then I will talk briefly about NASA, but I know you all have more questions for me than, so I'll just allow you all to ask me questions, right? But I was born in Trinidad and Tobago. Anybody knows where that is?
Tobago?
Tobago. Trinidad and Tobago.
Yeah, I know.
Where is it?
In Africa?
No! So far. Oh my gosh.
Sorry, I know this country, but I know where it is.
You heard of Jamaica?
Jamaica, yes.
Cuba, of course.
Yes.
Puerto Rico.
Yes.
Yes. So those are islands, right?
Yes.
In the Caribbean. So Trinidad and Tobago is one of those islands.
Okay.
It's the last island. So you have the US here, and then you have all these little islands that come down like this. And then Trinidad is the last island, and it's 7 miles off the coast of Venezuela or South America. So it's right there. So I was born there. And I grew up there through high school. And then I migrated to the US 35 years ago. What can I say? I loved math and science, so I did really well in math and science. That's all I did, actually, in high school. That's all I wanted to do. That's not all I was allowed to do, but that's all I really wanted to do. And I decided I wanted to be an engineer. I loved planes, and so I was going to study aeronautical engineering, which is a design. There are people who design planes, right, and build planes. So that's what I wanted to do when I went to the US to study, to go to college. And then NASA, I didn't know NASA existed, actually, at that time. I was telling the other group that it's not like now where you have YouTube, you have the internet, you see these SpaceX launches, Elon Musk, right? SpaceX, right? Yeah, like you see this happening all the time. I didn't have that when I was growing up. First of all, that didn't exist. Probably NASA and the Russian Space Agency, but I didn't have that. So I moved to the US, and that year they were flying the space shuttle. We were flying the space shuttle for years and years, but that particular year, one of the launches blew up and killed 7 of the astronauts on board. It was the Challenger accident, the Challenger space shuttle. And so that's when I became aware that there's this place called NASA that's so cool. There's something called a rocket and a spacecraft. I didn't know that before. I only knew planes exist. I didn't know rockets existed. And that there were people who flew in space called astronauts or cosmonauts on this side of the world. And so I was like, oh my gosh, that's what I want to do. So I kind of shifted a little bit in what I was studying in college, and ended up with a degree in mechanical and aerospace engineering. And 6 years after I moved to the United States, NASA hired me. Now, it wasn't that easy. I mean, a lot happened between then, but I'm not going to bore you with that story. But that was 25 years ago. I've been working for NASA for 25 years. That seems long, right?
Yeah.
How old are you? You're like 15? No. How old are you guys?
I'm 15.
What? So,
Vamos com a technology. 13, both of those.
13. So this is the range 13 to like 16 maybe? 15. Oh, 13 to 15. Okay, yeah. 17. Oh, cool. So no, 25. Yes. I've been at this place. I'm really old. I'm much older than I look, I think. Anyhow. So I have done like amazing things. I worked on the space shuttle. I used to test the systems on the space shuttle to make sure that they worked when they went to space. I worked on the International Space Station. Oh, so I want to tell you guys, maybe I'll talk about this after. We have a website called Spot the Station. You know about the International Space Station, right? Because that's when you launch in from Baikonur. That's where the cosmonauts are going and the astronauts. They're heading to the International Space Station. It's 400 kilometers above the Earth.
Yeah.
We have 6 human beings who live and work in space on the space station for 6 months at a time. Imagine that. Like right now, they're orbiting the Earth and they stay up there for 6 months. And we do science experiments on the space station. So why, you would ask, why you do science experiments? Well, we get to take gravity. So there's no gravity on the space station, and that's a whole physical thing of the speed it's going and free falling. And so you see them, when you see pictures of them, they're floating, right? So there's very little gravity, enough to be like canceled out. And so we do a lot of experiments in that environment. You know, we study the human body for sure. Things happen that things happen differently there than they would here. And we could talk about that if you have questions about what happens to the human body, you know, when they're in space. We study things like cells and how to grow plants in space. We study how fluids especially behave in space, because they don't behave like they do here. You know, when you have a glass of water and you pour it and the water just flows? Well, it's flowing because the gravity, like the gravitational force, allows it to move that way. In space, it doesn't flow. It becomes bubbles, right? So the gravity, when you remove gravity, water behaves like in bubbles. So if you go on YouTube, astronauts love to like do this. They blow the bubble and the water is all over the place. So you can see those. But so we learn there are unique things that happen to living organisms and physical processes that we understand here. It's different there. So we use the space station to really understand that more. And so I worked on that program for about 8 years. And then I've worked on the Orion capsule. So the Orion is our next human command module. A lot like the Soyuz, but it looks a little different, and it's going to be able to take astronauts to the moon. So that's the next thing. We want to send astronauts to the surface of the moon by the year 2024. And you'd ask, okay, didn't you go to the moon already? Yes, we went there 47 years ago, but we've never been back. And so in order for us to go to Mars, which is what we want to do one day, is send humans to Mars, we got to learn how to live in that environment away from Earth for a long period of time. So we're using the moon as that, like what we call a stepping stone before we go to Mars. So so that's what I'm working on now. So I said the Orion capsule will take humans, astronauts, to the moon. And so what I'm working on now is we're going back to the moon, but we're first going to send robots, and we're going to send rovers to rove around the moon like you see on Mars, because we need to find what's the best place that astronauts should be able to land on the moon. And so we're doing it differently. We're going to pay like Elon Musk and SpaceX to transport our instruments to the surface of the moon, right? So it's a lot like I said, FedEx or DHL or DHL.
Yeah.
And if you want to send a package to another part of the world, you would take it to the DHL office and you'll pay them and they'll take it and they'll ship it. We're doing that with the moon. We're going to the companies and say, hey, could you take our instruments to the moon and we'll pay you for it? So that's the program I manage. And so we'll start doing that as early as next year. You'll see like little landers landing on the moon. It's not easy at all. The Israelis tried to do that a few months ago. Did you hear about that? It was called Bereshit, and they tried to land on the moon, and they were really close. I mean, they transited to the moon, they circularized their orbit, and they were about to descend onto the lunar surface, and just before they landed, they crashed. So it's not easy, but we're gonna try and do that starting next year. So that's really a little bit about what we're doing. We also have rovers we send to Mars, of course. You know about Mars Curiosity,
Yeah.
right? Yeah, it's on Mars right now. Before that, they had the two little twin rovers. Do you remember that?
I forgot his name.
They were called Spirit and Opportunity.
Opportunity.
Yes, tiny. Opportunity survived. But so they're roving around Mars. So we just landed another one back in November called Insight. It's not a rover, it doesn't move, it stays in one place, and it's gonna drill into the Mars surface into Mars and study quakes. Like we have earthquakes, they are Mars quakes. So that lander is gonna study what are these quakes about, and we've started to hear like sounds, like kind of like woo, 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 sounds like, you know, there's some seismic activity on Mars. And next year we're gonna launch another rover, a lot like Curiosity. It's called Mars 2020. And this one is gonna drill and pick up Mars samples, put it in a little tube, and it will drop the tubes along its way on Mars, just like little footprints. And then a few years from now, we're gonna have another spacecraft that will go and pick those tubes up and bring it back. And that will be the first time we bring soil back from Mars. Really, we've never done that before, right? So that will be exciting. And we have other program. We have a spacecraft that's orbiting the sun right now, and it's, I mean, literally like right up against the sun's corona. So it's the closest we've ever got to the sun, and we're studying how the sun behaves. That's really neat. That we launched that last November. So that's really cool. And then we have Hubble Space Telescope.
Yeah.
And you see those amazing pictures of the other galaxies, right? So we have a follow-on to Hubble Space Telescope called the James Webb Telescope that we're trying to finish build. It's been 10 years in the making. But that's gonna look out, so the Big Bang Theory, when we believe our universe first started, like was created. So James Webb is gonna look all the way back in the past to that, when that first star and the first galaxy was created. Hubble cannot do that, but James Webb is going to be able to do that, which is going to be amazing. Because we're always asking, how did our universe evolve? How did it come to be? You know, that's one question. What do you think the other question is that we want to answer?
Where it's going to end.
No.
Does the university have walls, for example?
No.
No.
Besides, how did the universe evolve? What do you think there? Is there life? Is there other life forms in the universe?
I listened to one program called SETI. They finding another lives in the university SETI.
Oh, SETI. They always looking. We are always looking for kind of evidence. We don't know if there's other life. I'm sure there is. Like we are not the only life in this universe. There's no way. But we are always looking for, what we're looking for are planets that are like Earth. So Earth-like planets we call exoplanets. Exo meaning they're outside of our solar system. They're in other galaxies. But they may be orbiting their sun or their star. Our sun is a star. We call it the sun, but it is a star. They may be orbiting their star at the same distance that Earth is, and maybe at the same speed. And we think if we identify those, which we have identified about 1,000 of those that exist right now in other galaxies, that maybe there's an atmosphere, and if there's an atmosphere, then maybe there's water, and then where there's water, you can find life. So that's why we're interested in Mars. Like, we knew Mars had water at one point in time in its history. So where there's water, water is like one of the building blocks of life. Not human life, but life. It could be microbial life, bacteria, or cells, but life, some kind of life. So we are always looking for that. So that's what SETI, part of SETI's job is to do that, to scan the skies, looking for, you know.
What will happen if scientists will find another planet with life or something like that?
What will happen? I don't know. We'll be like, okay, well then we are not alone. We'll have evidence for not being alone. Well, we are not alone, but we'll actually have evidence that there is other life out there.
That's really cool.
It is cool, isn't it?
Yeah.
I think it would change how we look at ourselves as humans. Yeah. So questions? I know you have burning questions about space and NASA.
How do you find your own way to became a scientist in NASA?
I don't know. Like I told you, I didn't grow up dreaming about NASA because I didn't know about NASA. But I knew that what I love math and science. And math and science is the foundation for engineering, any type of engineering. And then to be a scientist, a professional scientist, right? So that if you have that, if you love that and you're doing well, then, you know, you have so many options as a career. And so, I mean, I told you when I heard about NASA, then I was like, yeah, that's where I want to be. But I was already on the path because I was already studying engineering. And so I was very attractive for them to hire because I had the skills that they were looking for, you know?
Is it hard to be a scientist engineer in NASA? So in NASA, they have a high quality for scientists.
Yes. It's super hard. Yes, yes. Because look at the things we are able to do. Look at the amazing things that we have accomplished. It takes really smart people to do that. I mean, it's real rocket science, right? So it is a very difficult environment to be in. But like everything else, you just bring what you know, you work hard. You're amongst a lot of smart people, so you gotta have your stuff together, you know? But yeah, it's hard. I mean, we've progressed in terms of women rising to leadership positions and stuff like that. So we're doing a lot better with that. We don't have many people who look like me with my color skin, you know, so we can do a lot better with that. But yeah.
Oh, have you ever seen Elon Musk?
Have I seen him in person? I actually went to his office. I don't know if he was there that day. I don't know if I've seen him in person. But I've visited SpaceX, and it's a pretty neat place.
For my mind, is Elon Musk like a god?
Of course, for all young people, he's a god. Why is that, by the way?
Oh, because he is a wonderful human. I think he just creates some wonderful things like SpaceX, Tesla, where he's saving our planet and he building something like rockets or something.
Yeah.
In my mind, like, oh yes, he's really good.
Yeah, he's a visionary for sure.
Yeah.
Yeah. Other questions?
You've been a finalist in astronaut
Mhm.
thing, but
Mhm.
have you been space?
I have not. I have flown in the aircraft that we simulate zero G, so I've experienced floating in like a microgravity environment, but I haven't been like to the space station.
How was that in zero gravity?
It was pretty cool. One of the coolest experiences I've had ever. So the plane goes up to like 30, I think it flies up like 33,000 feet, I believe. Yeah, the US does it in English. And it levels off, and then it starts parabolas. So it does this deep dive that way you get the zero G, and then it comes back up and you get 2 Gs. So you're constantly going from 0 G to 2 G, 0 G to 2 G, you know, like that. And so you experience 0 G for a few, you know, probably a minute, not long. And then, you know, so that was a pretty neat experience. By parabola 32 out of 34, I was reaching for the vomit bag because I was like, oh my God. But I managed to hold it together. But you could imagine that it's like being on a roller coaster, right? It's pretty similar to that. So, anyhow. Other questions?
Да, конечно.
Можно ли подстроить человека, то есть модернизировать под другие планеты, то есть, чтобы он смог жить на планетах, где нет жизни?
So the question is, do you believe that one day, as we figure out that it is possible to live, one day be able to kind of redesign, to upgrade a human to live in that planet?
Upgrade a human. Tell me a little bit more about what you think. What do you mean by upgrade a human?
Что вы имеете в виду немного более...
Like more intelligent?
Сделать его более умным или непосредственно организм, тело человека каким-то образом усовершенствовать, чтобы он мог жить...
Непосредственно тело, чтобы он смог, например, дышать без кислорода и...
So that's more about the actual body. So to make a human being to be able
to live in
oxygen, for example, or something like that.
No, it won't happen.
Такого не будет.
You know why? Because the human body, our human body, was created in this environment. Earth, 1G, 1G. So any planet that has 1G, yes, we could survive. Because we were made in a 1G environment. When you take it out of that environment, Mars is 1/6 or 1/3. I always get mixed up. The moon is 1/6, Mars is 1/3 G. Then you wouldn't be able to survive without help. Being in a suit that allows you to breathe like how we breathe here. Because our body is created for this environment. So the astronauts on the space station and the cosmonauts they go through a lot of different physical changes with their body, right? They lose bone, they lose muscle because they're floating. So they don't need those things. We need it because we are in a 1G. We need to walk, we need to stand, we need to sit. So we need a skeleton. They don't use that, so they lose it, which is why we make sure that they do 2 hours of exercise a day, every day, to keep them healthy, right? To keep their bones relatively strong so that they don't lose it. They also have problems with their eyes. Some of them, not all of them. Some of them, their eyesight gets worse. It gets bad to the point where they come back, it doesn't reverse itself. So we kind of know why that happens, but we don't know why it happens in some and not all the astronauts. And it happens in the males and not the female astronauts. So what's going on there? So we're trying to understand that. Because you could imagine if you send an astronaut to Mars or a cosmonaut to Mars, it's a 6-month journey there. They have to spend at least 2.5 years, 500 days is maybe 1 3/4 years there, and then 6 months back. So that's 3 years away. And you could imagine they can lose their eyesight, and it would be like, okay, what are you able to do at that point? So we are trying to solve all those challenges on the space station. That's why we use it. So that when we are confident we can send astronauts to Mars, that they will be healthy, they'll get there, you know, and they can explore and stuff like that. Did that ask if that answers?
Yes.
I have something to say.
Yes.
It's not a question, but did you know that Pluto, Russia is larger than Pluto?
Ah, I didn't know that.
Yeah, that's right.
We used to think Pluto was a planet. Now it's not a planet, it's been downgraded. So many people are upset about that. But Pluto happens to be the largest body in the Kepler belt. And the Kepler belt is right at the edge of our solar system, and it's this belt of rocks, all kind of rocks. And Pluto happened to be the largest one, so scientists identified it, and it looked like a planet, right, because it was so big. But it's just one of many rocks in that Kepler belt. So that's why they said, no, you're not really a planet. You're just this icy body, thousands. Yeah. But we were able to send the probe to the New Horizon probe, and you saw those beautiful images of Pluto, right? Yeah, with the heart. Do you remember the images of Pluto? You should look it up on the internet. It's so beautiful. You see a little heart. Anyhow, it's sulfur or something. But we always have to put it in the things that we understand. So we understand hearts and stuff like that. But yeah, really cool.
Question.
Yeah.
Do you remember the most craziest idea that was discussed with NASA? For example, I've been reading that the Chinese trying to build a solar space station to collect the energy from the sun and transfer it to Earth. Or, for example, Japan Space Agency are trying to build a space lift or something.
Elevate, yeah, that space lift elevator, kind of elevator to space, has been around a long time.
Yes, and the idea is that have you ever heard or been involved in this kind of discussions in NASA? And is there this kind of mad and crazy ideas?
Yeah, well, I mean, so no, I haven't been involved in those kind of discussions because I've always worked on programs that we know we can execute it, we know it's feasible, and we know we could build it, or else we would not be pumping money into it. But there are always those ideas, not necessarily from NASA engineers and scientists either. They have researchers in universities that study space. I mean, you know, they do research in space. and they come up with some of these ideas, tethers, putting a tether to space. You know, there are different ideas of how you can access space. Propulsion example, you know, not just chemical propulsion, there are a lot of other ideas like using antimatter as a propulsive source and stuff like that. Those things we've never built or demonstrated that they actually could be done, but they're all like these theoretical concepts, you know?
The last thing, it links with the previous question. So, is there any news in NASA about the EM drive?
About what?
EM drive, the new engine for the rockets?
EM drive. Electromagnetic, I assume EM. I'm sure. We have a center in Ohio, Cleveland, Ohio, that all they do is propulsion research. Now, I don't know about electromagnetic. I know they're doing ion, solar electric propulsion. And we're actually thinking of that as the propulsion solution for one of our spacecraft. So, yeah.
Можете перевести вопрос? Почему Кассини так безжалостно отправили в атмосферу Сатурна?
Отправили кого, извиняюсь? Cassini.
Cassini.
So why you just sent Cassini to the space with
Saturn.
no mercy?
Нет, Сатурн, в атмосферу Сатурна.
Oh, to the Saturn, yeah, to the atmosphere of Saturn.
Why?
Yeah, so.
That's the question. Why?
Yes, because basically he meant that you just sent him to do whatever he
Exploration.
to do, but
So we didn't know what Saturn, I mean, we have theories about what all the planets are like, but they're only theories. We don't have any real evidence. They're just theories. So we create these satellites or probes or whatever to actually go to the planet to study it, take information, send it back so we could support the kind of theories that we understood about the planet. Does that make sense? Can you translate that?
Экспериментально.
Ну, как бы, а почему?
There's never an intention to bring them back.
То есть и планов не было возвращать обратно их.
They go,
Изначально уже план был того, что они пойдут туда, что-то отправят, но сами не вернутся.
and it's built with a certain life. So we know this mission will be 5 years, for example, orbiting Saturn. And then at the end, we actually know when it's going to die. When the propulsion system runs out, when it runs out of fuel or whatever, we actually know that. So we design it with that in mind.
То есть изначально было задумано так, что будет отправляться спутник на определенное время, отработает свой жизненный цикл там, они знали, что закончится жизненный цикл, то есть система приведения в движение аппарата, она то есть уже и живет себя, и все. То есть планов возвращать обратно не было.
It's just metal. Why? So tell me more about why you asked that question. What is your concern?
Что вас беспокоит во всем этом, во всей этой ситуации больше всего? Что непонятно?
Да, жалко, много денег своих.
Spent a lot of money for that, right? And just kind of wasted it.
No, we didn't waste it. We learned so much about Saturn that we didn't know before.
Но в то же время все недаром. То есть, несмотря на то, что он не вернулся назад, тем не менее, очень много информации было отправлено, мы узнали очень много о Сатурне.
А в конце концов, можно же было бы спустить на какой-нибудь из спутников Сатурна?
Do you believe there was a way to actually kind of attach it, to bring it back and attach it to one of the satellites, the Saturn satellites, and
No.
kind of try to bring it back?
No, we don't have that
Не было
capability.
такой возможности, на самом деле.
It wasn't designed like that. And we knew that it couldn't do that.
Потому что сама не была рассчитана на то, чтобы такие операции с ним проводить.
And we don't need to do that because we have instruments on board that actually take the data, whether it's a camera taking pictures that send back to us. So we are getting information of information.
То есть изначально не было такой идеи возвращать обратно, зато на аппарате внутри есть все системы, которые собирают информацию, снимают видео, фотографии и прочую информацию и способны ее передавать уже на Землю. И вся идея этого аппарата заключалась в том, чтобы получить эту информацию, ничего более.
Yeah. Now, on the other hand, to one of the asteroids called Bennu, right?
Да, теперь у нас миссия, вот мы задумали миссию на один из астероидов, который называется Bennu.
The mission is called, the spacecraft is called Osiris-Rex.
Osiris-Rex. Да, так называется аппарат, будем говорить космический корабль небольшой, который отправится по их задумке туда.
And Osiris-Rex is going to take a sample from the asteroid and bring it back.
Идея этого аппарата будет заключаться в том, чтобы на астероид приземлиться, взять образцы с астероида, ну непосредственно почвы или, скажем, поверхности, да, будем говорить, и привезти обратно это все на Землю.
And so that's one where we're going to bring a sample back because it's a solid body, it's a rock, so we can actually bring a sample back, learn about what makes up these asteroids, right? So we're always looking for more information on how did our solar system evolve? Why are some planets gaseous? Why are some planets solid? Saturn is a gaseous planet, so there's no solid sample you could bring back. So we're just studying the atmosphere of Saturn. There was nothing to bring back.
То есть идея сама заключается в чем? Мы постоянно проводим эксперименты, пытаемся постоянно получать больше информации, и все это ведет нас к одному большому вопросу. Как наша система солнечная вообще зародилась и развивалась на протяжении многих лет, да? Вы знаете, что некоторые планеты, они, будем говорить, не являются скалами, то есть они имеют мягкую поверхность типа Земли. Некоторые же планеты, в частности Сатурн такой мягкий, некоторые же планеты и прочие тела космические, они просто скалы. В частности, как раз на астероид это огромная глыба, просто скала, где нужно отломить кусок и просто привезти на Землю.
Good? We good?
Понятно ли?
I have a question. Voyager 1, it's got out of solar system.
Yes.
Do you still get signals from it or some information?
Yeah, they still get signals from it. It's like, right, it's crossed, I forget the name, they call it the heliosphere or something, where it's crossed out the boundary where our solar system ends and you're going into, you know, the rest of our galaxy. But yeah, they still, you know, they can still track it, which is amazing. Because Voyager 1 launched in 1972 or something. It's the longest operating spacecraft ever built. It's amazing.
It's been already 50 years.
Yeah. And there's Voyager 2 that's on its heels. But yeah, they...
74, right?
Yeah. But they still get information pinged back. It takes a long time, right? It takes, I mean, you could imagine to get back from Mars. So when you're way out there, it takes a much longer time. You have another question?
Yeah, I have one of Jupiter satellites.
Jupiter.
Yes.
Yeah.
Satellites. It has a lot of ice on it.
Titan?
Yes.
Titan.
I don't remember it.
Or Europa. I get mixed up too. But yes, we call them the icy moons.
Yes, icy moons. Yes, something like this. Do you plan to launch your rocket or something like this to it?
Yep. So we have a mission right now to Europa. It hasn't started. We're still building it. It will launch, I believe, in 2023 or something. And last week, we just announced a mission to Titan. And this will be cool. This is a dragonfly. It will be a helicopter flying around the atmosphere of Titan. So that would be really cool. So yeah, but that's late 20s, 2026, I believe. It takes a while to build, develop these spacecraft, test them, and then launch at a certain time when they will actually get to the place you want them to get to. But yes, we're actively doing all of that. Pretty cool. It all helps us understand Earth too. How did Earth come about? How did Earth evolve, Getting information about all these other planets are kind of like puzzle pieces for us understanding our solar system and then our planet too, Yeah.
There is a theory that universe is donut like that one. And do you plan ever in future to send a spacecraft to go through universe and maybe come back to Earth?
We probably don't have that capability. I mean, do you have to do that? We have the Hubble Space Telescope. How much information, how many things we've learned about the the distant universe through pictures and images from Hubble Space Telescope. You don't necessarily have to send things. Telescopes help us see the distant universe. And we can learn a lot about the distant universe just by that information. So you don't have to send things out. And the universe is expanding. So it's not conical. It's not, what did you say? No, it's not a donut. It's expanding that way. It's like you started here, the Big Bang, that's what we think. And it expanded out. And our solar system is at the edge of that expansion. And it keeps expanding. So, yeah. Yes?
A month ago in Instagram, in NASA group, I see a photo of a project of Elon Musk, is a global internet.
Yes, Starlink, it's called. Starlink. Mm-hmm.
NASA was working with this project.
All Elon, all SpaceX. They built their satellites. They're a private company, right? So they can do what they want with their money. So they built all these satellites. It's going to be 4,000 at the end of the day. They've only launched 60-something, I believe. That was what happened a few weeks ago. But in all, they're going to have 4,000 orbiting the Earth at about a distance of 1,500 kilometers above Earth. And yeah, they want to provide internet access to all places across the world that don't have it. But they're not the only company. There's a company called OneWeb that's doing the same thing. Their satellites are a little smaller. SpaceX's satellites are about OneWeb satellites are about 600 kilograms, and they're a little lower in altitude. But yes, they are. That was not a collaboration with NASA. That was all his private kind of product line. Yeah. So he doesn't only want to launch rockets or transport satellites to space. He also wants to create this communication network and sell that service so that people all across the globe could have internet access or access to broadband. Yeah, you're welcome. Good question.
Да, конечно.
Oh.
Считаете, была ли наша Вселенная создана или это случайность?
So, okay, your personal opinion. Do you believe that someone created our galaxy, or is just
You can't put me on the spot like that.
Accident thing? So, очень сложно в данном случае.
An
На
accident?
который нужно еще постараться деликатно ответить.
Okay, I may get killed for this.
Я
I
сейчас
don't
скажу
know.
кое-что.
It's my personal opinion
Мое личное мнение.
that we evolved. It was an evolution.
Планета на самом деле создалась но не в том виде, в котором сейчас, а создавалась, эволюционировала на протяжении многих лет и пришла к тому состоянию, которое сейчас.
We're trying to understand what caused what caused the reaction in the first place, Big Bang. There was like an explosion. What caused that? We don't know.
Сейчас мы проводим работу, чтобы понять, изучить и исследовать, что же явилось причиной так называемого большого взрыва, да, вот по этой теории, что вызвало эту реакцию, которая привела впоследствии создание вот такой планеты.
But every element that you can find in the universe, we are actually made of it.
Но опять же, химических элементов, которые вообще существуют в галактике, да, во Вселенной, как раз вот Земля, мы все как раз созданы из этих элементов.
Carbon, oxygen, nitrogen,
Карбон,
all those
кислород, азот и все эти элементы.
Hydrogen, helium, all of those elements that we find in the universe, we actually find it here, which means that we are a part of that.
То есть, иными словами, все эти элементы, газы, будем говорить простым образом, это как раз они все были найдены во Вселенной, то есть в галактике, когда проводили изучение, сбор из образцов. И эти все элементы присутствуют здесь на Земле у нас, что, естественно, наводит на мысль, что мы как раз являемся частью вот той как раз Вселенной, которая нас создала.
So that's my personal belief, and
это мое личное, скажем, такая вера, и к тому же
the job of a scientist is to find evidence of our natural world.
Ввиду того, что я еще и ученая, и работа ученого как раз заключается в том, чтобы находить доказательства, улики именно натурального, естественного происхождения.
To gather the data,
собирать данные, информацию,
analyze the data,
анализировать информацию, данные,
present it to the public,
а затем обнародовать, то есть рассказать всем об этом.
And allow the public to make up their mind on what that means.
А уже общественность, то есть люди сами будут решать, во что они хотят верить.
Scientists don't make a judgment on what we find. We just find.
Ученые мы не нами или исследовано как бы комментировать или придавать этому какую-то концепцию. Мы просто находим и представляем то, что было найдено.
And Albert Einstein was the same way.
И то, что касается Альберта Эйнштейна, он был абсолютно точно таким же.
He was a believer that there was something bigger, right? But he also found he theorized how our universe operated, worked with space and time and energy and mass. But he also believed, even as a scientist, he had a belief that there was something bigger.
Вы знаете, да, то, что касается Альберта Эйнштейна, он тоже говорил о том, что мы не одни, и существует на самом деле нечто большее, чем Земля во Вселенной. И когда он непосредственно свою теорию разрабатывал, выдвигал, он провел, то есть научные исчисления, когда соотношение массы, плотности разных параметров и компонентов, которые существуют, и пришел к выводу, то есть выдвинул теорию, каким образом образовалась Земля. Но в то же время он понимал и говорил о том, что на самом деле существует нечто большее, что в процессе чего или какой-то, скажем, реакции или действий чего-то большего получилось так, что Земля зародилась.
Does that answer her question?
Ответила ли я на ваш вопрос?
Excellent, thank you. You have another one?
Может быть, у вас еще один вопрос есть?
Oh, okay.
Да, конечно.
Как вы думаете, мог ли произойти большой взрыв от, собственно, взрыва газового сверхгиганта?
Okay, do you believe, or maybe do you think that that Big Bang was just caused by some particular gases which were kind of accumulated somewhere there, and that was just an explosion? Повторите, пожалуйста.
из-за расширения взрыва сверхгиганта, сверхновой.
Or someone else, like a giant thing, a way bigger than an Earth, exploded, and the Earth just became a part of it.
Oh, okay. I'm not a theoretical physicist, so I don't study the Big Bang. I just know what I know from a perspective of design and crafts to study it. I think we are trying to understand what happened. Really, we're trying to, that's why we're building this James Webb Space Telescope. So,
Вы знаете, я не физик-теоретик, то есть не занимаюсь разработкой или изучением каких-то именно физических теорий, но тем не менее хотел бы сказать, то есть и как раз то, что касается Большого взрыва, я не занимаюсь этим, но именно как с точки зрения именно ученой, которая занимается физикой, механической в частности, как раз хочу сказать, что вот этот новый телескоп Веба, да, который они сейчас строят и хотят скоро запустить, он как раз рассчитан на то, чтобы заглядывать туда подальше и увидеть что-то, что как раз могло бы ответить на ваш вопрос, что могло стать причиной того, что произошла вот такая реакция, которая впоследствии образовала Землю.
but scientists believe there was this big reaction, this explosion of helium and hydrogen gas, which is really which is very abundant in the universe, right?
Да, но вот ученые, они верят о том, что именно реакция при соотношении водорода и гелия как раз вызвала огромный взрыв, который как раз, вот, скажем, явился причиной.
But there are other particles found in our universe. Anti-helium, we're looking for all these anti-helium and anti-protein kind of particles. So there were other things reacting or that evolved to such a point where all these planets and bodies came about. But we're trying to understand, we don't know exactly. At least we don't have evidence, right? We have the theory. Big Bang is a theory, but we have no evidence to prove that that theory is right. So we're trying to understand and answer that question. What is the origin of the universe?
Да, но и как бы эти газы, они не единственные во Вселенной, то есть масса существует других прочих газов. И как раз мы сейчас ищем так называемые антигазы, то есть противовес вот тем газам, допустим, тому же самому гелию, да, что могло бы пойти в реакцию несовместимую, которая могла бы вызвать взрыв. Но опять же, не забывайте, что теория Большого взрыва это всего лишь теория. Пока нет прям полного набора доказательств и улик, которые бы конкретно сказали, да, тут произошло так. На данный момент это всего лишь теория, и как раз для этого мы и работаем, чтобы найти больше каких-то информации, данных, которые позволили бы нам ответить на вопрос, как зародилась Земля, и в частности наша Солнечная система.
Good.
Spacecraft from Star Wars can be real life when the spaceships disperse to a speed of light and get to another place of the universe.
I mean, you want to translate? Yeah.
Да, такой вопрос задали. Как вы думаете, вообще в будущем возможно, что такие же корабли, которые показывают в «Звездных войнах», да, будут в реальности существовать, когда, допустим, корабль может быть запущен куда-то с одного места в другое место на скорости света, да?
Up to today, it has been fiction,
По сегодняшний день это всего лишь фантастика,
not reality.
абсолютно нереалистично.
Is it possible? I'm sure. Maybe in the future.
Возможно, что да, в будущем.
It's clear that right now we can develop something like that. Or maybe it's not really even can we develop from a feasibility perspective. Is it practical? I think is more the answer the question we try to answer.
На сегодняшний день такие корабли мы вот как бы не рассматриваем как практичные. Мы даже не думаем, что вполне возможно, что можно как-то постараться создать такие корабли, но опять же, исходя из рентабельности, да, исходя из нужности таких кораблей, пока мы это не рассматриваем.
A lot of times in these movies, you see the spacecraft with huge centrifuges, right? Like the Martian was one. You remember when they left him there, they thought he was dead and they were coming back to Earth. They had this huge spacecraft with the centrifuge, right? Where they were simulating gravity. So we have thought about those concepts. We've studied those concepts like in real life, but they're not practical.
Да, и очень часто в таких фильмах, где про космос, про корабли, вы видите, что, в частности, «Звездные войны», да, вы видите, что их корабли обычно это такие большие центрифуги, да, на основе центрифуги, то есть они пытаются имитировать создание гравитации при помощи этих центрифуг. Мы думали об этом, то есть, но пришли к выводу, что на данный момент даже при помощи такой центрифуги это невозможно.
So feasibility is one thing. Practicality is another thing.
То есть, конечно, здесь два момента. Можем или не можем. То есть, является ли это, скажем, вообще возможным сделать. Это один вопрос. А второй вопрос, будет ли это впоследствии практичным. Нужно ли это.
Make sense?
Понятно?
I always say make sense.
Что вы хотите? Там в «Звездных войнах» звуки,
So
в
cute.
космосе взрывы и огонь. Что там вообще?
So that's like actually the Star Wars movie. There's a lot of things which kind of you can find a lot of those incompliances because you can hear the sound in the space,
Yeah.
which is impossible, and some other stuff which
Yeah.
is kind of incompliant
Yeah.
with what is
Real, exactly. That's what science, it's called science fiction, not always science fact.
Поэтому так и называется жанр, то есть научная, да, фантастика или фикция.
We thought by now we can teleport people to other places in the universe. We can. I mean, in Star Trek, right? Star Trek, they were teleporting to other planets, and so we can do that.
То есть, или, допустим, телепортация, да, вот в Star Trek можно видеть, что просто телепортируют людей с одной планеты на другую. Нет, мы этого делать не можем.
Yeah. Maybe you'll invent it.
Может быть, ваше поколение сможет это делать.
Yes.
For your opinion, people is a helper of universe or antibiotics?
Say that one more time. In my opinion, do people something? People, maybe you could say it in your native language and he'll translate.
Да, конечно, пожалуйста. Вот.
Люди, они помогают, скорее, галактике, или это просто какая-то ошибка в коде? Можете это
Я не могу. Я извиняюсь. Имеется в виду, не могли бы объяснить чуть-чуть?
Да.
То есть, отправляясь в космос, люди помогают.
Люди созданы по какому-то разумному пути, или это какая-то ошибка?
Okay, all right, хорошо. All right, the question is more about humankind.
Uh-huh.
It's like, do you believe that we just an accident, or someone had a plan for us and actually created us with a particular plan?
That was her question. In essence, kind of similar. My personal belief, this is not to influence anybody, is that were we an accident or was there a plan? I think we were an accident.
В какой-то степени ваш вопрос созвучен, вот, девушка тоже задавала. Знаете, мое личное мнение, не хочу, чтобы как-то на ваши убеждения внутренние это повлияло. Мое личное мнение, мы своего рода случайность.
I think we evolved. I mean, there's evidence that we evolved, right? It was the question about can we, I don't know if it was when, but can human beings survive on other planets without help of a spacesuit? The answer is no, because we did not evolve in that environment. We evolved in this environment.
Но опять же нужно подходить к этому вопросу так. мы продукт Земли уже, то есть человечество. Мы не прилетели вместе с Землей, не создались вместе. Вот как раз отвечая на его вопрос, вопрос молодого человека был, смогут ли люди как-то потом, скажем, регенерироваться или там получить какое-то усовершенствование своего организма, чтобы жить на других планетах. Нет. Почему? Потому что мы исключительно являемся продуктом этой планеты. Мы не появились людьми сразу, а мы эволюционировали из чего-то, может быть, из клетки и так далее, и так далее. Понимаете, да?
But I do believe that we are part of something bigger, you know, we are part of the bigger, the vastness.
Но в то же время, не отвергая другую теорию, я хочу сказать, что мы всего лишь часть чего-то огромного, большего намного, чем мы можем представить.
Now people call that different things.
И вот это большее люди по-разному называют.
Like God, Creator,
Бог,
Universe.
Создатель, кто-то говорит просто это Вселенная или, то есть.
But I think at the end of the day, it's all similar. We just look at it from different perspectives.
Но я думаю, что в конце концов, на самом деле, это в конце концов, это что-то одно. Просто люди разные, по-разному, или это кого-то там.
But I feel like as a scientist, I kind of have a different perspective, you know?
Но я ученая, понимаете, да, и у меня, соответственно, есть свои взгляды на эти вещи.
You're welcome.
Please join me in thanking Dr. Alleyne.
Давайте поблагодарим.
Time goes so fast. Oh my gosh.
Так, время быстро пролетело.
Well, I hope it made a difference for you. I hope you were inspired. I think my message is that you can have big dreams, regardless to what that is. It doesn't have to be flying in space or building spaceships. It doesn't have to be that.
Я надеюсь, я могла быть вам полезной. Я надеюсь, что вот эта беседа, наше с вами такое общение станет для вас своего рода вдохновением. В частности, основным посылом моим сегодняшним для вас является: ребята, у вас у всех есть мечты, да, и нужно свои мечты к ним идти. Пусть это будет не космос, пусть это будут не космические корабли, но у всех у вас есть свои мечты, к которым нужно стремиться и идти, и верить в них.
It could be whatever, as long as you have a big dream and you're willing to work hard, right? And you're willing to be determined and persevere. I don't know how that translates.
То есть, если у вас есть большая мечта, вы понимаете, что она сама тоже не пройдет. Если у вас есть мечта, значит, соответственно, она может осуществиться только вкупе с трудолюбием вашим, с вашим упорством, с вашей конкретной определенной целью, к которой вы будете целенаправленно идти.
No matter where you come from, because I came from this small dot. I mean, like literally a dot, a fraction of what your country is. I came from this small place.
И неважно, откуда вы родом, какие у вас семьи. Допустим, я приехала из местности, которая буквально маленькая точка на фоне Казахстана. Маленькая небольшая точка.
But I grew up to do some amazing things, right?
Но вот у меня получилось, я как бы выросла и впоследствии сейчас занимаюсь изумительными, интересными вещами.
So even if you come from Kazakhstan or Almaty, you can, I mean, make such a huge impact on the world.
И у вас у
If
всех
you
есть
wanted to.
шанс. Вы с Казахстана, вы с Алматы, допустим, и у вас есть в будущем сделать нечто, что повлияет на весь мир.
Yeah, that's it.